Hello, my friends. Okay, so we're going to talk about the rational zeros theorem. I'm just going to get right into it. Okay, so the rational zeros theorem. So it's kind of got a lot to set up to it. Okay, so you've got a polynomial. So this is just the way that we write out polynomials. So you have, this is your leading coefficient, and then you go all the way down to some constant term. Okay, so what the rational theorem says is you let p over q be a rational number in lowest terms and also a zero of f of x. If this is true, then p is a factor of the constant term, the last term here, and q is a factor of the leading coefficient. All right, what? What the heck does this mean? All right, this is actually very cool. There's just kind of a lot to unpack here. The important thing to remember is that the number on top, so it's all the factors. So anything that can divide into the constant term, that's what goes on top. And then anything that can divide the leading coefficient, this term here, that goes on bottom. So what this is talking about actually is a combination of possibilities for the zeros. This is probably easiest if we just do an example together, right? Okay, so we want to find all possible rational zeros and then factor into linear factors. Okay, so this is a little bit tedious, but remember, p is a factor of this, so this part is my p. Q is the leading coefficient. Okay, so let's just mark those. This is going to be the factors of p, and here's what's going to be my q. Okay, so what this means then is, so for my p's, it's plus or minus 4, and then what numbers divide into 4? That would be 2 and 1, right? So those are all my possible p's. That's what this is getting at. And then for my q, so it would be plus or minus 2 or plus or minus 1, because only 2 divides 2, right? So now we come up with our p over q. So we have to come up with all possible combinations of this over this. So what I suggest doing is you try to be very systematic about this. So let's take 4 over each possibility here. So my possibilities are plus or minus, so 4 divided by 2 is 2, right? And then 4 divided by 1 is just 4. Okay, so there are the first two possibilities. So now let's take 2 over each of the q possibilities. 2 divided by 2 is 1, so I can just write plus or minus 1. 2 divided by 2 is 2, which we already have. Finally, we have plus or minus 1 over 2, plus or minus 1 over 2, and then plus or minus 1 over 1, which again is just 1. So what this theorem is saying then is these are the possible rational zeros of this polynomial. So that's kind of cool. The other side of this is these are a lot of things that we're going to have to test in this polynomial. So yeah, let's giddy up. All right, so let me clear some space. Okay, so I've just whittled down the information that we really need. I need to factor this into linear factors, and I don't know, I have no idea what my possible zeros are, so I'm just gonna, yeah, we're just gonna start testing, my friends. Okay, so let's see. Let's try, I don't know. Actually, let's try 2. I feel lucky with 2. Okay, so I've got 2, -1, -8, and 4. So the nice thing is with synthetic division, at least this goes quickly to calculate, right? So 2 times 2 is 4, this becomes 3, 4 times 3 is 6, and then -8 plus 6 is -2, -2 times 2 is -4, and 0. All right, I just want to say I didn't even prep this. I just went in blind. I am just a good guesser. I feel the numbers, I guess. Okay, so anyways, I'm being ridiculous. So what does this mean? All right, so I talked about in my other video on the factor theorem, like how to kind of interpret this. So since I have a 0 here, 2 is a 0. What's the associated factor? The associated factor would be x minus 2. And then what polynomial is this? So this polynomial, so remember we start in the x squared column. This starts x squared, x is constant. So this is going to be 2x squared plus 3x minus 2. So that is what I have boiled this down to. So let me clear some space. And now let's let's just try to factor this. So we've got 2x and x, and then let's see. I'm going to say that this is plus 2 and minus 1. So if I do this, I get 2x squared, and then the last term is negative 2. So 2x times 2 is 4, minus 1x is 3x. So I have this factored right. So check it out. I have this factored down into linear factors. Cool. One other thing I want to point out about this. So what are the zeros of this polynomial? So my zeros are 2, 1/2, and negative 2. So if I just set each one of these factors equal to 0, so to do that, just to be clear, so I set each factor equal to 0. So if x minus 2 equals 0, that means x equals 2. If 2x minus 1 equals 0, so if you take a second to solve for x, you will get that x equals 1/2. So that's, you set each one of these factors equal to 0. So notice the 3 zeros, 2, 1/2, negative 2, and were those in our list? Yes, they were. 2 and 1/2 were both in our list. So what this means is that you could have guessed a different factor, and then you still would have eventually factored down to the same factors as me. So if you had started with 1/2 or negative 2, your synthetic division would have looked different, but ultimately when you factored everything down, you would have gotten the same factors as me. So it's a little bit of like luck of choosing the right factor when you're doing this. So let's try another one. So now I've got 5x to the 4th minus 19x cubed plus x squared plus 31x plus 6. Same deal. So first I've got to figure out my p's and my q's. So this is my p, this is my q. So for my p's, factors of 6 are 2, 3, and 1. And then for q, this is just plus or minus 5 or plus or minus 1. Okay, so for all my possible p over q combinations, so what I'm going to do is I'm going to take each number here and then just go through putting it over here. So 6 over 5 and 6 over 1, which is just 6. And then we'll shift to the 2, so this becomes 2 over 5 and then 2, and then 3 over 5 and then 3, and then 1 over 5 and then 1. So there are my possible p over q combinations. Whew. All right, so now let's make some space and let's give this a try. Okay, so I have this list now. So trial and error. Let's just choose something. I don't know. Let's try negative 1. Okay, so I'm gonna have 5, negative 19, 1, 31, and 6. So let's see, I'm going to bring down the 5. 1 times negative 5 is negative 5. This becomes negative 24. I don't have a very good feeling about this, but let's see. This becomes 24. This becomes 25. Oh, maybe this will work. This becomes negative 25. 31 minus 25 is 6. Oh, wow. And then negative 6 and 0. All right. I am a champion level guesser. All right, so now what do we do with this? Okay, first of all, what is the factor here? So the first factor I found, remember it's always the opposite sign for that 0, so the first factor is x plus 1. What is this resulting polynomial? So this polynomial starts with x to the 4th, so this is going to be the x to the 3rd column. So the polynomial that I got in the division is 5x cubed minus 24x squared plus 25x plus 6. So let me clear some space. Okay, and so now here's my challenge to you. You've kind of seen how this works. So now we need to just repeat the process for this polynomial. Notice that the leading coefficient here is still 5, and then the constant here is still 6. So this list, it still counts, okay? So what I would say is just make a wild guess, see if you are right, and see if you can finish factoring this, and then hit play when you're ready or when you're stuck. All right, so I'm going to make another guess. And I'm going to set up the synthetic division for that polynomial that I factored. So let's go ahead and do the synthetic division. So let's see, bring down the 5. 2 times 5 is 10. This becomes negative 14. Negative 14 times 2 is negative 28. Oh my God, I am like the master guesser today. Okay, so I've got my remainder of 0. So now how do we interpret this information? X plus 1 was that first factor. Now the next factor that I found is so remember, it's always the opposite sign. So the next factor is x minus 2. And now I interpret this polynomial. So remember, we were starting now with an x cubed was my degree, so 3 was my degree. So this is going to be the x squared column. So this becomes 5x squared minus 14x minus 3. So let me erase this. And now we just want to factor this quadratic. And I am just going to go ahead. So, okay, I need to obviously get up to 15, and the factors of 3 are 3 and 1. So clearly I need to bounce 5 off of the 3. So we'll make this a minus 3 and then a plus 1. So then notice I get negative 15x plus 1x. See how I did that? And then I figured out that makes negative 14x. Okay, and so now, whew, all right, we did it, friends. We factored it. So sometimes you might have a little bit of trial and error with this. I mean, just try to look at the results that you get and see if you can make better guesses if you're not selecting the right P and Q. But sometimes it really just does come down a little bit to like a guessing game. Sometimes I guess something, I think it's not going to work out, and then it ends up working out. So at least synthetic division is quick, but I don't have like a great mechanism, at least with this theorem, for how to choose your P's and Q's. Although I will talk about in some other videos some other theorems you can use to help kind of guide your choices. Okay, so if this was helpful, consider just liking the video, commenting, sharing, subscribing. And otherwise, I will talk to you guys in another video. Thanks for watching.